morning. Today we are going to start the third unit. It is about linear function and relation. Linear function and relation. In this, first of all, we will try to understand the meaning of the terms. Linear. Linear means a function in degree 1. When the highest power of the variable is 1 in a polynomial, when the highest power of the variable in a polynomial is 1, it is said to be linear. It is said to be linear. Clear? Now we will try to understand the word relation and function. Relation and function. Linear functions and relation. So relation and function. Many times you have plotted the graph, right? What did you notice? What is the graph? In the graph, you try to show the relation between the two variables, x and y. When you plot the ordered pairs on a graph or on a grid, you get variety of graphs. You get different types of graphs. Sometimes you get point, sometimes you get line, sometimes curve, sometimes parabola, sometimes circle, sometimes triangle. Any kind of geometrical shape can be obtained by plotting the set of points on the grid. Right? So, the relation describes how the two variables are related, how the two variables are connected or related. This is the basic definition of relation. Relation it describes how variables, for example, x and y are connected. Right? Because when you plot the set of ordered pairs, you get different type of shapes. Is it okay? So this basically describes the relation between the variable x and y. Is it okay? Let me show you this relation mathematically in terms of equation and inequation. One is y is equal to 3x plus 2. This is a linear equation. Right? And this here you can have a relation between x and y. From here you can study the relation between x and y. How x is connected to y. How x is linked to y. Let us have another equation. X is greater than y. This also gives you the relation between x and y. The relation between x and y is that x is always greater than y. X is always greater than y. So, through this equation and this inequation, this is called as equation because we are using equal to sign. This is called as inequation because there is inequality sign. Less than sign or greater than sign is called as inequality. Is it very clear? So from these two, you are able to get the relation between the two variables x and y. Is it okay? So these both are a relation. Like this, we can have several more examples to give the relation between the two variables. Is this very clear? Now, let us try to understand the function. What is function? For a relation, you don't have to worry. You can write any kind of equation. You can write the equation of a straight line. You can write the equation of a parabola. You can write the equation of a curve or a cubic function. You can write the equation of a circle. You can write the equation of ellipse. Any kind of equation you want, you can write. Anything that comes to your mind, you can write. And you can say that it gives you the relation between the two variables x and y. Now, when we come to function, right? Let us try to understand from these two first of all. Is this okay? These two are giving you the relation. If you have these two equal, this equation and this inequation gives you the relation. But which one of these two is inequation? Is a function. Which relation is a function? These two describes the relation. But from these two, which one or which of them describes the function? Is it okay? From there, we'll try to understand the function. First of all, now, in this equation, for this equation, if you take a value of x, you take a value of x. Suppose your x is equal to 0. Any value of x we can take, right? So when you take x is equal to 0, right, you will have a value for y. For the value of x is equal to 0, you will have a corresponding value of y. And that y you can calculate by putting the value of x in this equation. Are you getting me? So when I put this value, 3 into 0 is 0, 0 plus 2 is 2. So therefore the value of y is equal to 2 when x is equal to 0. So for a particular value of x, for a fixed value of x, you will have a particular value of y. Means when x is equal to 0, y will be only 2. Y will be only 2. Are you getting me or not? For this value of x, you cannot have any other value of y. For a particular value of, for this value of x, you will have a fixed value of y. Similarly, if I take another value of x, again I will have another value of y. Let us see one more example. When x is equal to 1, then 3 ones are 3 and plus 2, 5. So therefore y will be equal to 5. Look here. Now when you have changed the value of x, you have got a value for y, a fixed value of y. Is this okay or not? Now, from here we can try to understand the function. This is, first of all, we said it is a relation. This is a relation, right? But this relation is also a function. This relation is also a function. Why? Because for every value of, for a particular value of x, you are getting a definite value of y. Am I understood or not? For this value of x, you cannot have any other value of y. Is it okay? That means x is equal to 0 is linked with y is equal to 2. x0 is connected to y is equal to 2. Right? So there is a one-to-one connection. There is one-to-one connection. Is it okay? If I say this as input, if I say this as input, then this is your output. This is your output. So for a particular input, there is one and only one output. If this is so, then that relation is said to be a function. That relation is said to be a function. Now let us come to this one. X is greater than y. X is greater than y. That means if I say y is equal to suppose 3, because this is applicable to any value of x and y, no? So I can assume, let us take a value of y is equal to 3. Now what it says, x is always greater than y. That means any value which is greater than y will become the value of x. That means the value of x will become 4, 5, 6, 7, 8 and so on. Are you getting it? Because it is said that x is greater than y. When x is greater than y, that means if y is taken as 3, then x is any value which is bigger than 3. So therefore we can have infinite solution. Is it okay or not? So if I say now this is input and this is output, then for these many input there is one and only one output. Right? So we don't have here one-to-one link. Here we don't have one-to-one connection. And therefore this relation is only a relation, but this is not a function. This is not a function. Are you getting it? Now if I write the definition, a relation in which A relation in which each input has one and only one output is called as function. Is it very, very clear? So first of all, we try to understand this. We have three different strategies by which we will differentiate the relation from the function, right? So this is one of the strategy. First of all, we are trying to understand this in terms of equation. Please remember here, any equation is a relation, and that is always a function. Whether this is a linear equation or it is a quadratic equation. Is it okay? So any linear equation, let us focus only on linear function. Any linear equation is always a function. Because in this, for every input, there is one and only one output. Therefore, this relation is always a function. Is this okay? This is the one method. We will see the other methods also. Let us go into more detail of relation and function and then try to understand it in terms of this diagram. Okay. This is input, this is output, right? This is one set. Now, input, you can see that how it is connected. This input has got how many output? 2 output, right? And what I told you in the definition of the function, all these are a relation. If we have to write the relation, if we have to know about the relation, we don't have to look at anything that how the elements are connected. We don't have to know that how the elements are connected. Simply we have to see the arrows. Simply the arrows are drawn, and the arrows are drawn in any way, does not matter. It describes the relation. We have to only see the things carefully when we have to know about the function, right? Because for function there is a criteria. Every relation is not a function. Right? Only when each input has only one output, then we can say it is a function. Then that relation is a function. So one input should have only one output. One input cannot have more than one output, right? So this input has got 2 output, right? Is this a function? Because one input has got 2 output. If one input has more than one output, then it is not a function, right? So this is not a function. This is only a relation. Now, if I try to write this relation in terms of the ordered pair, it will make you more clear. I am writing the relation, right? A to 1, A1, then A to 2, A to 2, then B to 3, B to 3, then C to 4, C to 4. Once you write it into this form, then you can see the first element. Is there any repetition of the first element in any of the set? Is the first term repeated? If the first term is repeated in any of this pair, then that is not a relation. That is not a function. It is only a relation. So here in this case, you can see here in this set and then this set, in these 2 pair, the first elements are repeating. Therefore, this is not a function. Now here, this element has only one output. This input has only one output. This element has only one output. So each input has only one output. That means this relation is a function. Now if I write this all into pair, A to 1, B to 2, C to 3, is the first element. Is there any repetition of the first element? No. That means this relation is a function. So this is also one of the way. Now from here also we can do the same thing. we will make this into pair. So A1, here B2, then C2. Only look at the first element. Is there any repetition of the first element? This is A, this is B, this is C. No. Second element can be repeating. No problem. Second element can repeat. But the first element should not be repeating. Then that relation is said to be a function. Right? So this also is a function. Right? This first one is the function. This is a function. This is also a function. Is this okay? And this is not a function. Hope I made you clear. So there are two different ways till now we have discussed. When there is a linear equation always describes a function. So linear equation can always be said to be a function. Another is when each element has one and only one output, then it is called as then function. Is it very clear? When each input has once again we will try to understand the relation and function by means of this many diagram. Is it okay? So these are the different diagrams. This is a line, this is also a line, this is a parabola, this also is a parabola, it's opening sideways, this is another curve, this is a circle. Like this we can have a different type of geometrical shapes, right? Now the question is, which of these geometrical shapes describes a function? Which of these geometrical shapes describes a function? There is a very simple technique to know whether which of them is a function. All of them is a relation. All the diagrams gives you the relation between the variable x and y. So relation, there is no doubt. Every graph, every shape gives you a relation between x and y. But which of them is a function, right? To know that which of them is a function, there is a very simple technique. You draw a perpendicular line, right? You want to know whether this is a function or not, you can simply draw a vertical line. Clear? If that vertical line cuts this graph at one and only one point, this indicates that this relation is a function. When the graph is cut at one and only one point, then that indicates that that particular graph is a function. But if when you draw the vertical line and if the vertical line cuts your graph at more than one point, that means that relation is not a function. Not a function. So with that concept we can check this linear equation. You draw a perpendicular anywhere, right? You draw a perpendicular anywhere. This perpendicular, it cuts this line at one and only one point. So this is a function. Similarly, this is a straight line, right? This also is a function because here also when you draw a perpendicular line, it cuts the line at one and only one point. Therefore, this also is a relation. This also is a relation. This parabola also is a relation. But this parabola is not a relation. This parabola is not a relation because when you have drawn the vertical line, this vertical line, it cuts this shape at 2 points. One at this point, another at this point. Therefore, this is not a function. Now this is a curve. Now for this curve also you can draw a perpendicular line and you can see that this perpendicular line again cuts the graph at one and only one point. Therefore this is also a function. Now at the last we can come to the circle. You can again construct a perpendicular line and this perpendicular line cuts your circle at 2 points and therefore it indicates that this is not a function. Is this very clear? With this, now we can start the exercise. The page is on 70, page number 70. The first exercise of a linear function and relation is, we can move on to page number 70. And the first question is not to say anything because there are 3 diagrams drawn. You can look into the textbook and then you can justify your decision. You have to decide, you have to choose which one of them is a function. Is this very clear? After this we will move on to a question number 2. Alright, now we are moving on to question number 2. Question number 2, there are 2 parts, A and B, and we are taking it together. Okay, this is the part, question number 2A part, and then this is question number 2 part. B part. This is A part, this is B part. Now in the part A, your first column is the student's name and this is their age, right? And now let us see when the students were asked to give the age, then the teacher found that the age was like this. Karma's age was 14, right? Sonam's age was 15, Tashi also was 15, and then Pema was 16, right? So you can see here we have tried to establish a relation between the student's name and the student's age. So this is a relation, no doubt, right? Now, is this relation is a function? The first column indicates your input and second column gives you the output. So each input has only one output, because in the first column you have the name of the student and a particular student can have only one age, right? Can I say that my age is 52 and then my age is 48 also? Practically unreasonable, right? So therefore, each here in this case, in first part, each input has one and only one output, and therefore this relation describes the function. So if I write this relation in terms of pair, right, then you will see that there will be no repetition in the first place, and this is the indicator that this relation gives you a function. Now when I come to this part, the first column is now just we have flipped the column. We have flipped the column, right? Now the first column has become the student's age and second column has become the student's name, right? 14 is the age of Karma, 15 is the age of Sonam and then Tashi also, right? And then 16 is the age of Pema. Now in this case, when I make this into pair, right? This is the input, this time this is the input and this is the output, right? Now when I write this relation into pair, what you will notice is this 15 come in this pair and will also come in this pair. That means the first term, the input is repeating in more than one pair, and therefore this relation is not a function. Is it very clear? So in today's video, since we had lots of theoretical explanation, that is why numerical I am stopping it here only at question number 2. In the next video we will see the other remaining questions. With this, thank you so much. See this video again and again, because theory is very, very important. Without having the good concept of theory, you will not be able to enjoy the numerical part of this. So I will request you all to please view this video again and again. Thank you so much and have a nice day.